Fifth grade Go Math, Chapter 4, Lesson 4, Essential Question. How can you use expanded form and place value to multiply a decimal and a whole number? Before we begin Unlock the Problem, I want you to remember that these are different strategies on how to solve multiplication problems with a whole number and a decimal, and they are not the only way to solve these problems, but we are, again, focusing on just one strategy. And expanded form, the model that we're going to be using, is also known at some places as the area model. So let's keep that in mind too as we're working through this strategy. So looking at Unlock the Problem. The length of a day is the amount of time it takes a planet to make a complete rotation on its axis. On Jupiter, there are 9 and 8/10 Earth hours in a day. How many Earth hours are there in 46 days on Jupiter? So you're being asked how many Earth hours are in 46 days on Jupiter. The important information are one day is 9 and 8/10 Earth hours, and we need 46 days. So we can use our model and partial products to solve the problem. And so the problem we're finding is 46 days times 9 and 8/10 hours. So first thing that we need to do, step 1, is using this strategy, is to rewrite the factors in expanded form. Now remember, each of these are a factor. So 46 as expanded form, the 4 is 40, and the 6 is 6. 9 and 8/10 expanded form is 9 plus 8/10, and you can have that 0 there as well. And then step 2 is to actually multiply to find the area of each section, and the area of each section represents a partial product. So that's what this is. So what we did is we drew a box, and we have the 40 on one row and the 6 on the other row, so that these are 46. And then we have the 9 and 8/10. 9 and 8/10 split up with a line. So remember, the area is length times width, okay? And so we're going to find the area of this box right here. 9 times 40. Well, 9 times 4 is 36, and then my 0 we add, so that box is 360. And this box down here, it's still 9 and 6, so 9 times 6 is 54, so that's another partial product. Now we're going to look at this box right here, and it's 8 by 4, or 8/10 by 40. Remember, you can move the decimal out. 8 times 4 is 32, and then we have that 0, so it's going to be 32 with a 0. And then how many decimal places do we need? We need 1. So, oops, that was my finger. So it should just be 32 decimal 0, and you can just drop the 0 if you want to. So it's 32. And then our last one, right, this box, it's 8/10 again by 6. So I'm going to move my decimal out. 8 times 6 is 48. And then I have 1 decimal place, so I'll put my decimal in. So it's 4 and 8/10. So those are all my partial products. And my last step is to add those. And so I need to transpose or rewrite them right here below the timing. So 40 times 9 was 360. And I'm going to do a decimal with a 0 just to help me keep things lined up. 40 times 8. So I find that box, and that was this one. And 32. And I'm going to keep my decimals lined up. And then 6 times 9 was 54. And that one did not have anything, so I need to make sure I have a decimal with a 0 to stay lined up. And then my last one is 6 times 8 tenths, which was 4 and 8 tenths. So 4, lining up my decimal, and 8 tenths. And then I add all of those up, and you should get the answer of 450 and 8 tenths. And so that answers our question. It is 450 and 8 tenths in 46 days on Jupiter. So now number 1, what if you wanted to find the number of Earth hours in 125 days on Jupiter? How would our model change? Well, right here, we multiplied by a 2-digit number. So if this is a 3-digit number, how is our model going to change? How many rows would the model have at that point? Well, with it being a 3-digit number, we would have 3 rows, and your model would look like this. To where you have the 125 in expanded form, and then 9 and 8 tenths with your different squares to find the areas of. So another way is to use the place value patterns. It's the same as yesterday, where we're going to move the decimal out of the problem and then put it back in. And this is the normal shortcut that people use. So we're going to practice that again. A day on the planet Mercury lasts about 58 6/10 Earth days. How many Earth days are there in 14 days on Mercury? So you're being asked how many days there are on Mercury in 14 days. So how many Earth days? All right, so we're going to be multiplying that, 14 groups of 58 6/10 Earth days. And so we have our multiplication set up here. To remove the decimal, we multiply times 10. And then you work out your multiplication steps as normal. Remember, this is a place-holding 0 because this 1 is actually a 10. And when you multiply anything by 10, it ends in 0. And you would have added it all together and got 8,204. And then we have to place the decimal back in again. And so we'll have our digits. And then how many decimals are there? Well, we had to move 1 out. So there's 1 decimal place. So your final answer should be 820 and 4/10 Earth days in 14 days on Mercury. Now I know that went through fairly quick, but again, it's the same thing we did yesterday, pulling the decimal out and then moving it back in. So now looking at number 2, what if you rewrite the problem as 10 plus 4 times 58 6/10 and use the distributive property to solve? Explain how this is similar to your model using place value. Well, using the distributive property means that you would multiply this times 10, and then you would also multiply this times 4, one at a time, and that would give you partial products, which you need to add together. So the first part of your sentence should be you would multiply 58 6/10 by each factor, that's the distributive part, and then to get your final answer, you would add those together. Press pause if you need more time for writing your sentence. So let's look at the try this for find the product. A, they want you to use a model, so you would need to draw your box. Both of your numbers have 2 digits, so you're going to have 2 on top and 2 going down. Expanded form on that. So let's fill that in. 52, I'm going to put down the side. And so that breaks down into 50 and 2. And then 35 hundredths breaks down to 3/10 and 5 hundredths. And now find the area of each square. So I'm ignoring the decimal. I have 3 times 50, or 3 times 5 is 15 plus the 0, or adding the 0 to the end. But I need one decimal place in my answer, so that one is 15. The next square, I like to work down. Ignoring the decimal or moving it out, 3 times 2 is 6. But I need one decimal in my answer, so I'm bringing it back, 6/10. Next is 5 hundredths times 50. Ignoring the decimal right now, 5 times 5 is 25 with 1 0, but I need 2 decimal places in my answer, so it's really 2 and 50 hundredths. And my last one, 5 hundredths times 2, ignoring the decimal, 5 times 2 is 10, but I need 2 decimal places in my answer. And then I'm going to line up my decimals and stack them all. Then I add them all up. And my final answer is 18 and 20 hundredths. Next is to use place value patterns. So write it. I always write the one with most digits on top. Okay. Now just ignore the decimal and multiply it out, and then add your decimal in at the end. Digit-wise, 1, 4, 6, 8, 8. I have 2 decimal places, so my final answer is 146 and 88 hundredths. On your share and shows 1 and 2, they want you to use the model, so for number 2 you need to draw a square, and then 3, 4, and 5 you may use whichever method you would like. For say, press pause and work. So on number 1, you should have ended up with 14 and 25 hundredths, finding each square and then adding them together. Number 2, your square to start out with should look something like this, with 20 and 7 and then 8 and 3/10. It's okay if 8 and 3/10 is on this side and 20 and 7 is on top, as long as you have them split up like that. Those are the areas, and then you should have stacked them, lining up your decimals, and added them together. And your final answer should have been 224 and 1/10. Now for 3, 4, and 5, I'm going to use the method where you move the decimal out and then bring it back in. And for the sake of time, the answers are just going to pop up without much talking through. Number 3, there's 1 decimal place, 156 and 6/10. Number 4 is 1,290 and 3/10. Number 5. And number 5 should be 278 and 24 hundredths with 2 decimal places. So remember, using this model, the area model, is one strategy, but if it asks you to do that in the directions, you need to try it. Any other time, you may choose whatever strategy you would like, as long as you are able to understand the strategy and find the correct answer.